professional observatories, this is useful to have such a tool to have a quick result and to see if everything is okay, if we see the emission we are looking for, and so on. But after that, they will take the data and they will reprocess the data with their own tool, with their Midas, RF, or things like that, on Python packages more and more today. So, and this is really compliant with Demetra. So we do all the job, but at the end, we have very standard fits file. So if you want to take all the individual image and all the individual data, you can just do it.
Yeah, but you have the function to export to BES. So you have to the BES database, and there they require a instrument response correction. So should be working here.
Yeah, but again, it works. Today it works. Well, well, sorry, I have to run again. No, sorry, I'm not in the right observation. Sorry, this is where I was on this observation. This is why the data reduction was not done. Sorry, I was confused. And here I have the result of my observation. The response curve correction works. But we know that we have to make something much easier to use for everyday observations. Yeah. But it works today. Okay. And here, by the way, we have the export all button at the end, and then we can export all the orders in the standard format that is useful for BES database. So we comply to the BES requirements, which is considered today as a reference.
I was not sure, but is there already a atmospheric extinction correction or not? Is that
no? It's included. It's included in the response correction.
Response curve. Okay.
So maybe, maybe if we can do something better, we'll do. But today, my understanding today is that the best way to have a good atmospheric correction is just to have a reference star be close to your target and do it. So
yeah,
but.
You are presenting a lot of databases in the response function. Do you think that the Pickles database is high resolution enough?
Well, that's... Oh.
Hello, I'm sorry. My name is Thảo from Vietnam. So I have some time to talk with Francois and just to say hello from Vietnam.
Yeah.
I'm sorry to disturb you.
It's good to see you too. Good. Welcome. Well, sorry, I was regarding the yes, when we go to the data reduction and when you go to the response tool. Sorry. Why I cannot open I cannot open it because it is already open? No. Well, this is the demo effect.
You have to click on response curve.
Well, yes, but I have to click on the response, but the button is gray because I guess that
on the parameters. Okay, yeah.
I guess that I run no, I don't know. Oh.
Yeah, where parameters is under parameters, you need to click on response curve. Right.
No, but it is gray. It is gray. I cannot do it. I cannot select it. I don't know what happens. No, there is no. I guess that well, to not lose time, I will start it again. I'm not sure it will be enough. No, it is not. Well, I will restart Demetra. I don't know what happens, but this is now, in fact, we have a lot of databases in the software. These databases are exactly the same as the ISIS one. Well, by the way, I didn't talk about ISIS, but most of the algorithms we have in Demetra come from ISIS. Okay, so the calculation behind is very close to what we can have with ISIS. We work on the interface, and for some parts we work on our own algorithm, like for the calibration. But generally speaking, this this is exactly the same. And we worked with Christian Brill, who gave us all the algorithm for the data reduction. This is very important. And the databases are the same as for ISIS. Okay, so if I go to the data reduction, I go to the response, and now I can open this. And when I click on this, I have the can select the reference and have different databases. And in this is probably something that we'll still have to improve. But we have low resolution and high resolution. Sorry, the spectral references. I think that Pickles is really for low resolution.
Yeah.
I don't know exactly, and this is probably not the best one to use for the eShel.
But for the high resolution, you have, for instance, the LOD, but that's restricted in range of.
Yeah.
I used as an exercise. I used the miles. Maybe you can click on it. You have the words tous et où en français. Still in French. You have to translate those, by the way.
Okay, tous. Okay, all. Okay.
Good. But I use the miles, and that's working. But I still see that the automatic smoothing is not taking place. It's you see the absorption lines. You still see them from the reference star. Can you explain what?
Well, well, I'm not sure. Let's try to do it. If I take, for instance, I base my calculation. Well, I consider that my sun observation is a reference observation to calculate the response curve, which is not a good thing because this is not a or B star. This is not a hot star, so it's very. It's not probably not the right way to do it. But anyway, if I do that for the order number 34, and I go to the miles, and if it were, I take this part, for instance, again, this is absolutely not the right way to proceed, but I see the two images in this area, sorry, and then, well, I will have to activate the crop. Okay, so I see here my original. I see different things and I can use the buttons to display one part or the other. Okay, and I can see I can automatically display the position of the Balmer lines and atmospheric lines. Okay, and then here so you have all the curves that you can display. So which is the original data, the theoretical one, the division of the one by one, so this the IR curve, the smoothed IR curve, and also the corrected source, so which is the correction of the initial observation by the smoothed response curve. Okay, so you have all the combinations, and especially here you have the different things that are useful here, and you can see if you do that, you can see the effect on smoothing your data. Okay, so I don't know, Hugo, where was your question exactly, but you can play with the different parameters to fix to define the correct smoothing of your spectrum.
Yeah. Okay.
By the way, well, go ahead.
Yeah, I tried it and I left the defaults, and that was too noisy. There were too much absorption lines in the so-called smoothed profile. So my question is, for automation, all of this, what will happen?
Well, again, this is something to do for each observation. It really depends on what you are looking for in your observation. I say that because I know that a lot of eShel users are not spending too much energy with the response curve because they are more interested in the line profiles, and at the end they will do a normalization. So in fact, we don't really care about the response curve. But anyway, what we have today to do today, sorry, is really to do the correction, to do this response curve building manually with this tool. Okay, so there is no automatic way. I hope that one day we will be able to define these values of the smooth based on the spectral value and the actual value or actual resolution of the instruments and the pixel size and everything, and to say, well, okay, this is how much we have to filter to smooth the profile. This is not the case today, and well, we have a lot of projects, so I don't know which one we'll do in the future, but this is the idea.
That answers my question. Thank you.
Okay. I think that René Pierre, you had a question earlier, and we didn't had the opportunity to talk.
I'm not sure. Remember? Oh yeah, maybe. It's been a while. It's getting late in Hawaii too. One issue I had when I was running the calibration, the wavelength calibration, I'm using the old optics of the eShel, not the new one.
Okay.
So it's very kind of out of focus for the lowest and the highest order. Yep. And I think the first order at least, so my calibration, my wavelength calibration always stopped by itself. It could not find a solution because it was just too out of focus. Okay, so I just removed that order from the fitting, and it worked just well. But my very simple question is, should I crop the data right from the start to avoid having that section, or to have to deal with it later? Well, how would you approach that?
The approach is quite simple, quite basic. At the beginning of the process, so the third step is the order detection, and you have a tool here to help you to detect, to define what are the different orders. And in this system, you can see the image. So this is all the orders that have been detected. You can select, well, just to show you very quickly the different images. By the way, I can draw a rectangle here and set the threshold in the dark part of the image to see exactly the dark part of the image. In this case, I see that if I zoom in the image, I see that I can go to the down to the order 57 in this case. Okay, but this is where the system has detected the right and the orders. The only thing that you have to tell Demetra is, if I've displayed the sun image, in this case, I've selected the object image, and then I use this image. Well, I can always remove the head-up display. I see that this is the order 34. I know this is the order 34 because I have the H alpha, and then I have to select which order I do consider is I can select what is the order number 34. Okay, so this is something which is very important to do. So this is the only thing that you have to do. And here, when it is defined here, so you told Demetra that this physical, this geometrical order is the order number 34, then that's it. It knows where are all the orders. When we have done that, just to click on validate, and then you can select from which order you can go. In this case, we have selected from the order 30 to 55. Okay. I see here the Demetra has been able to detect the threshold, the orders up to 57. So I could increase that. Okay, but in this case, there is a risk, because it is fuzzy, that there is a risk that the calibration fails. Okay, but the idea is this one. So this is really at the beginning of the process that you define from which order to which order you go. And of course, the recommendation in the beginning is to start with a few orders from 32 to 40, for instance. It is faster. You understand how it works and so on. And then you can try to push as much as possible all the orders.
Yeah. No, that's what I did. But in my case, that's exactly what I did. But I saw that problem only when I did the wavelength calibration, when it could not find a solution.
The result, the solution. Okay.
Yeah.
So regarding the just to show you quickly regarding the calibration. So we do the calibration in two steps. We have a calibration detection. In this step, we will detect the calibration for two given orders, well, usually one in the blue and one in the red. And then we will use these two different calibrations to, after that, to extrapolate or interpolate to the other orders. Okay. And by the way, this is what allows us to say for people using au-delà, you remember that you have to be to tune very precisely the rotation angle of the camera to make sure that the spectrum is perfectly aligned with the image. We don't need it anymore that with Demetra, because with Demetra, in fact, we do the calculation for two different orders, and based on that, even if you have a rotation of 15 degrees, we can do the calculation and we can find all the intermediate orders. Okay, so this is the idea. So we start with the calibration detection, and here we have some tools. So the idea is that we have a central reference wavelength for these two orders. In this case, we have decided that the two orders we will work on are the 34, the H alpha 1, and the 50. Okay, and then for each of them, you can go to the results and say, okay, guys, if I zoom in this part, I see a gray band in the middle, and I just have to make sure that I just have to give one wavelength to Demetra, which is in this gray part. And to do that, we have a reference document. It is to be improved, but we'll do it. So this is a PDF file, very basic, and I just have to go to the. I know that in this case I am in the H alpha order, so I am close to 656 nanometers. So if I go to my reference document, I can go to this wavelengths. I hope that you can see my screen.
Yep.
And okay, so it's 6. Okay, so I am close to the H alpha here, and I can recognize the pattern here of these big bands, large bands. I hope that you can see what I mean. And this is this pattern. Okay, if I'm right. Yes, I'm right. I'm sure I'm right. So it means that this band here, this emission lines here, is this one, which is 6604. Okay, so I just have to say, well, I know one of the wavelengths which is in the gray part, and that's enough for Demetra to calculate the parameters of the system. And then we have a very powerful tool here that will make the calculation. So with this value, oh, okay, so we have made dollar is not a valid value. Oh shit. Okay, excuse me. And I can just run the calculation, and I will see immediately the result of the calibration. So you have a list of reference lines here, and you have the RMS, which is 0.008, which is of course very, very good. And you can visually see that all the lines that are detected are bright lines. So I know it works, okay? If you don't have, if in your case, René Pierre, if it doesn't work, if the calibration fails, you can still go to the reference line list, which is in fact the bottom part here, and you have an editor of the list of the lines. Okay, so you can add or remove lines to make sure that you keep only the lines that are detected in your case. Okay, so I mean that the algorithm is very universal. You can use it for any spectrum and any resolution and so on. But you may have to work on this reference line list.
Okay.
Okay.
Thank you.
Any other questions?
Yeah, I have a question on the masters on the hot pixel detection. The number sigma is set to 7. I played around with it and found that when I was increasing this number, that my so-called cold pixels disappeared. With cold pixels, I mean the absorption pixels, the absorption lines in the spectrum. But what's the reason to put it on 7? Is there a goal for it?
No. The world 7. No, it is a parameter just to. Well, we usually this parameter is a usual way to select the hot pixels, and well, I'm not sure why you have cold pixels that disappear. Maybe we can look in detail, but this is really, for me, this is a parameter. So you have the noise in your image, and the noise is specified, defined by the RMS of this noise, and the number of sigma is a way to define a threshold to consider that above this value all the pixels are hot. And usually when a pixel is hot, it's much higher than this value. But anyway, we can have to play with this value. But normally, if you increase the number of sigmas, you should reduce the number of hot pixels.
Okay.
And by the way, if you have found something which is not normal, again, this is very basic. If you find something which is not normal, please tell us.
Well, it was normal when I thought it was normal. I increased it up to 30, and it removed, in fact, my dips in the spectrum. Dips which were too sharp.
Okay, but I'm surprised because it well, maybe, but if you have some data, we can go in detail to see if there is something wrong somewhere. I'm surprised, but
I will go in detail on that. Come back to that. Okay, thanks.
Okay.
Yeah.
That's it.
Okay. May I have a question? So,
sure.
Where should I want to check the equipment for a long time. It doesn't use. So if I use the if I would like to see the laser function of the equipment, to check the equipment, how or where should I go?
You mean if you want to check if your equipment, your eShel is working properly?
Yes, from time to time.
Oh, okay. So from time to time. So you mean when you are in usual observation, what is to check to be sure that your observation is correct, right?
Yes, that's right.
For me, this is a very interesting question. I think that there are some important parameters. For instance, you can look at you can check that your order detection is perfect. So the spectrum itself did not move in this image. If I look at this image in the bottom part, just to make sure that your spectrum has not moved. So all the orders are always exactly the same place. You can also check that something very important. You can check the calibration, if the calibration is correct. Okay, and to do that, you can look at the RMS for each order to make sure that the calibration is okay. And you can also click on this show calibration button, and it opens an image with all the calibration lines that are detected in the image. Okay, and you can zoom in it, and you have the wavelengths for each of the value. And when you see, in this case, you can see that all the lines are perfectly in the middle of the image. And even if I change the threshold, for instance, so I increase the threshold to better see the image, I see that all the lines are catched in the circles. So it means that the calibration is okay. Okay, and then I think that the other thing I would do from time to time maybe is to observe a reference star, always the same star that you know perfectly, and for a given exposure time, check that the level of your image are the same. Okay, so I think that if you do that, well, maybe your other people have other ideas, but I think that if you do that, that's you know that your instrument is correct.
So thank you. And for the second question is maybe it's quite complicated. So would you mind to write a manual for using the Demetra?
No, I don't want to. No. No, of course we have to work on the documentation. By the way, we already have a documentation. And we can send to you. I don't know if Alain, if we send it with the link to the beta Demetra version. We can do that. And the problem with the documentation, it is never perfect, it is never updated, and it is very, very difficult to keep up to date. But we will do our best. Something important is that we have made for the LP version, we have done several video tutorials. If I go to the Sheliak website, I have an English keyboard. And if I go there, if I go to well, the simplest way is to go through the website. Oh, it is slow. And I go to products, to Demetra software. And then here, so this is the page where you can download the software, not the beta version, okay, but the normal version. And then we have a link to the YouTube channel. So I don't know if you have seen these videos tutorials. So we have them in French and English. And now we have, I don't know, almost 20 tutorials for the LP. And well, I think my plan is to do the same for the eShel. But I don't know what you think. I'm interested to have your feedback on that. Would it be okay, or do you prefer a written manual?
In my opinion, I would like to have a written manual because for the newbie, it's easier to read and to follow.
Yes.
Okay.
I agree with that. My experience of supporting astronomers for 20, 30 years at CFHT and ESO is I would suggest a manual which would be a cookbook, okay, for people just to go through. But eventually you also have to describe the algorithms that behind the old machine, because if it's too much of a black box, you know what's going to happen, right?
Sure. So I totally agree with that.
Even the simplest things, like when you pre-process, you create a masters, for example, and things like that, people will want to know what's happening in the box when they push the button. So it doesn't have to be in the entire manual, but the cookbook.
Did you see the documentation that we have already done, or not at all?
Sure, absolutely.
Sure.
Yes, quite a bit. And I use Odela as well, quite a bit.
I mean, no. I'm talking about the documentation for the Demetra, the eShel Demetra version. Did you see it? Yeah?
Yes.
Okay. It doesn't match what you are asking. So I mean, a kind of cookbook and explain how to go step by step.
The cookbook is fine. The cookbook is no problem, okay? But when you click on a button like fit something or whatever, and you have a bunch of numbers for the polynomial popping up. Okay. I know where it's coming from because I've done that a lot in my life, but at some point this will have to be explained for people what's happening. I mean,
Okay.
if you use IRAF, for example, I mean, Americans, most people in spectroscopy have used IRAF for 30 years, okay? IRAF, you can set all the parameters and great details and all of that stuff. So you can control to a T what's happening. There's almost no black box in there. And I'm not saying that Demetra should go back to IRAF. On the contrary, I think you're way ahead. But at some point, I think you need to describe a little bit more the algorithm to see what's happening in the back.
Okay. When I'm dreaming and when I'm trying to figure out where we'll be in 10 years from now, I think that most of the algorithm will be in Python and will be open. So I mean that better than explaining the algorithm, we'll give you the code. In fact,
the code,
you can edit it and you can adapt it and you can improve it. And
well,
but at the moment we made the decision to write under Windows because most of the observers are working under Windows. And that's it. But okay, I take your points regarding the documentation. I'm not very surprised. So you know, we have a lot of a big part of our activity, which is with amateur astronomers, even for the eShel, and half part of our activity with professionals. And in fact, I know that the amateurs prefer the tutorials, video tutorials. I'm not very surprised, but it's interesting to hear you. So it means that we have to do both. And I don't know you, but the time is going too fast. So we'll do our best. We'll do our best. But okay, I understand your point.
I can tell you something interesting. The first time I used Demetra with Alpi, I was kind of very intrigued by the way you triggered observation from the data reduction. This is kind of very unique. I mean, you define your basket and then you trigger, or if you prefer, you trigger, you make sure that you do the right observation to trigger the basket, right? To get the right information.
Yeah.
The right. Yeah. It's extremely rare in professional astronomy that you do this. And I think it's a very good idea. I like the idea.
Yeah. Well, one of the key of Demetra is that we can process the data in few clicks just because we have prepared the right data at the beginning. So this is the idea. But I think this is not very rare because I know I discussed with some professionals and I realized a few years ago that 10 years ago, 15 years ago, when you have to go to have an observation, you went to the observatory and the observer used themselves the instruments. This is not true anymore. Nowadays, the instrument is far too much complex to allow an observer just to come and use it. So it is more and more the question for engineers and technicians to operate the instrument. And in fact, the idea is really to do that. We just have to have a pipe, process pipe that takes the right data at the beginning and that go through the process and give the results. And really, this is what we try to do with Demetra, I think.
Yeah. That's good. That's good. I developed the queue system at CFHT here, so I know all of that new thinking and stuff. But it's kind of cool that you did that. But I was kind of surprised the first time I opened the software. It was like that.
Okay.
And I congratulate you on this idea. It's
Thank you.
A new way of doing things. It's great.
Perfect. We are in phase. Okay.
I have a basic question. How do you switch between the Alpi version and the eShel version? If you have, for instance, the eShel beta version, can we use it for Alpi?
Yes, so I like this question. We say that we want to have one software dedicated to one instrument. So this is why we have the Alpi version of the Demetra, beta eShel version, and the LISA version. But in fact, behind, of course, this is exactly the same software, and we can switch from one to the other. The main difference is that for each version, we have the demonstration image linked to the instrument. So if you have the eShel version of Demetra and you switch to the Alpi version, you will not have the Alpi demo images. That's it. Okay, and we did that because the demo images are much bigger than the software itself. So if we want to cover all the instruments, you will have huge files. Okay, and the other point is that we will have. So I click that. The other point is that we'll tune the software in a good way. Now, if I go to the main window here, I see that I am in the eShel version. You can see my screen. Is that okay? Yeah. Okay. So you are in the eShel version, and now if I go to the manage observation, I have the session parameters here. And in fact, I can switch, for instance, I can go to my data for the ALPI, demo ALPI images, okay? Now I am in the demo image. I have the demo images for the ALPI, and I just have to go to the session parameter and tell that the process, I want that now it is the ALPI, okay? And that's it. And now I am in ALPI mode, and I see that I'm in ALPI mode. Okay, that's very basic.
Okay. I have another question, not related to eShel or ALPI, but to the LISA. I tried to use the software, the ALPI software, Demetra software for LISA, and actually it worked very well. I was surprised. But I have a question about the photometric slit. I had to define the part non-photometric of the slit to get it working. Is that taken into consideration?
Well, I'm not sure. We're talking about the ALPI or the LISA, which is not this is a little bit different to what we are doing. But if I look at my images here, for instance, I take the image of Vega here. In fact, you can select the bands in the ALPI version. You can select the bands in which you consider that you have your spectrum and your slit. Okay, so if you have only part of the slit which is used in your case, you can just change the deselection. You know what I mean? But again, we are not. This is not eShel anymore, but the idea is the same. By the way, you have seen that when I change in the session parameter, I change the process from one instrument to the other, so I can switch to the LISA, to the eShel, the WhoopShell. And when I do that, in fact, it changes a lot of things. This is what you said, René Pierre. In fact, we have all the pipes, all the pipe which is different. So when I switch to the ALPI, the data reduction steps are not the same. So it is shorter to process single order data instead of eShel. Okay, this is just really the main parameter in the Demetra is which process you will use, and a process means one instrument. That's it.
Any other question?
We can stop here.
Okay, maybe we can conclude on some insight of on the new version to come in, for Demetra.
Yes, well, good point. Thank you for reminding. So this is a beta version. Well, as you can see, it works, and we have more and more people using it. So I'm confident that it works, and we have some improvements to put in the software. I think mainly regarding the output tab. So to improve the how to have great images, PDF or PNG images at the end, we have to improve the data, the response curve correction process. So how to build the response curve, and we'll probably add. We need to add the merge functions to merge all the order together. Okay, so this is what we have to do in front of us, and well, right now at this moment we are working on a version which is more dedicated to the LISA and the ALPI. So we will release a new version for the ALPI and I hope for the LISA in few days, weeks from now. And the next one will be again focused on the eShel. And then I hope it will be the release candidate for the eShel. Okay, so in this case, we'll have a good tool for response curve correction, and we'll have something very complete and beta tested and so on. Now, for the next steps, so I know this is a big task that we have in front of us. I hope it will last for a few months only. And then after that, really our what we want is to have a software that is really that evolve with your needs. So if you have need any special function, please tell us. And well, of course, if you find bugs, because I'm sure there are still bugs in it, you will tell us. But I want that this software is alive and can evolve with your own needs. So in my mind, it will be always a technical software, so we'll not make science with it. So I don't want to put any, I don't know why, the reference line or emission lines, recognitions or things like that. So we'll stop really at the technical part. But sorry, there is somebody who is. This is the time where we have the deliveries. I want to. Sorry, so I missed what I was saying. So I will stop to the technical part of the software, but really, if we can improve it, please tell us, and that's it. And I hope that in a future, not too long, then maybe we'll adapt it to either Linux world, or we will open it to a Python algorithm for each step. Because in fact, we have defined with Demetra some standards with the observations, with the steps, data reduction steps, and so on. So we could use this standard to have something more and more modular and more open to you as observers, to your students also. And well, this is the idea. And of course, I'm interested to have all your feedback.
Thank you. So thank you for all of us to be part of this meeting. Before to leave, I would ask you some words about if we succeed to meet your expectation, or if not, what you would like to listen in a new meeting. Could we begin with you, Tao? Tao?
Yes. Can you hear me?
Yeah, that's right.
So, I don't have much to say, but first of all, I would like to thank you for providing me Demetra, because for me it's easier to use compared to the other lab and ISIS and even DECH, a program from people from South. So I'm working on the Demetra, and I hope to get some data, good data for, and I will come back to you. So I still following you, and I hope that for the newcomer like me, because you already have some experience of using instrument, but for me it's quite new. So something written down is better, and even I can give and I can cite in my publication, and I can send it to other people to find the document. And to have maybe I hope we have meeting next time and I have something new to share with you.
Thank you.
Good.
Thank you.
Thank you. Misha?
Yes, for me it was really impressive to see it as all the line, really a big step. And I'm really I'm really willing to reprocess my all data with this software and see if I get better results. It is possible to just load into the baskets all the observations and process them, yes?
Sure, it is.
So it's really impressive. It's a big step forward that we actually were freed from the Odela chains. So
yeah, good.
I really congratulate you. It's really a good work. So I enjoyed it very much, and I'm really anxious to start working with it. So
thank you.
Thank
Wonderful.
you.
Thank you.
Sar?
Well, I completely agree with Micha. It looks excellent and very easy to use. And I think that if something is easy to use, people will use it. So I think it is an excellent book.
Thank you. Thank you. Frank? Frank, your mic, we don't hear.
Sorry, I want to say thank you very much. You have done a great work and very good programming. Up to now, we haven't used it due to lack of a Windows PC. Actually, we are using Linux only with Indy and remote control observation. But this is a fact that we have to set up a new Windows PC, and the first software which we will install is your software. Thank you.
Okay, good.
Yeah.
Just one comment, Frank. So thank you. And one comment. Personally, at home, I'm also working under Linux. And well, by the way, my PC is under Linux, and my observatory is under Indy. And we don't know yet how we'll manage that, but either we'll have an Indy client instead of in parallel of ASCOM to be able to catch the images. We still work under Windows, but we'll be able to talk to the Linux equipment. And maybe the other option we have is to do that under Linux and to be able to import some data collected with any other software, including Linux, and to import them in Demetra and then process as if it were done manually. But well, this is I have the need. Personally, I have the need.
I try to install Demetra with Wine, but I haven't had success.
It's hard. Anyway, okay, thank you.
Thank you. Pierre? Pierre?
Thank you, guys. First of all, for making spectroscopy available to about everybody. These little machines that you've created in hardware are just amazing. And every time I go up to the students with these, 9-inch elastron and take some spectra with LP and everything, it's just amazing to me that we can do that today. And it's because of you guys. You had this development, first of all. And with now the suite of software you're developing for this instrument, I think they're going to be even more powerful. And it's opening an easier way to give access to spectroscopy to more and more people. Everybody is doing amazing images these days. Much easier to do imaging than 20 years ago. And it's extraordinary what the progress has been done. But spectroscopy has always been a little bit behind, and not anymore. And thank you also for being close to your users. I know that you communicate a lot, you listen to people around and take our comments into action. So we're looking forward in the future, at least on Malachi here, to work with you guys and get more spectrograph and get some data and use Demetra. So thank you.
Thank you very much. Wonderful comment.
We finish with Belgian team. So Guy, please.
Yes. Well, of course, it's a big improvement. It's far more efficient now to reduce the data. It goes all much organized, more organized. It's clear you see what you're doing and the output is already processable. There are a lot of things I would add to the system as a whole, or improvements. Maybe why not control the guiding camera? Because now you have to have a program separately for the guiding camera. Maybe that's something we can evolve. And the other thing we would like to have is some increase in efficiency. Now I am dreaming, because we're limited to, with our 40-centimeter telescope, to stars which are about magnitude 6 with the thing. So if you could increase maybe with another fiber to go to magnitude 7, 8, would be a nice thing. And the other problem we have now is the focusing to the imaging camera. So we installed new collimator at the entrance, but I hear from Hugo that we now have problems focusing the whole spectrum from 3,800 to 8,000 angstrom on the imaging cameras. So there are still little improvements here and there on the technical side that would be very welcome as well, to make it a very efficient and streamlined tool for processing, making data. So good work.
Okay, thank you. I just had a comment to what you were saying. Some part are really related to the hardware regarding the how to focus from the whole spectrum. So maybe we still have to work together because you should be able to focus all the spectrum at the same time. And the new collimator is only an improvement, so there is no drawback, I think. And regarding just a comment about the guiding feature, I don't want to put the finger on this feature because in fact we already have many tools that do that perfectly, and because I don't have enough time, energy, money, and so on, I want to focus on where we have some added value, and really I think that we already have a lot of things. So this is really not my priority to work on the guiding. But I understand the point. This is, well, more generally, this is complex because you have a lot of software that control the whole observatory, like ICP or like the SkyX or software like that. But the problem is that when you are doing imaging, you always have the same needs. So you can have something universal and that works for any combination. But when you are doing spectroscopy, you always have some specificities, and then you have to put the hands on and so. I think that we'll never have a total, a full package of software that control an observatory in spectroscopy. I think that if we want to do that, we have to go to the open source software and we have to go to Python to be sure that we have the most of the package, and then you have some modules that you can do yourself to adapt to your own application. But anyway, we could spend hours on that.
Okay, Hugo, your mic is...
Okay. This was a very fruitful meeting, and I hope we can meet again in a couple or 3 months from now concerning the same subject and the improvements. So I have nothing to add. It's a very great product, and yeah, keep on the good work for all of you.
Thank you. Hugo,
Thank you.
You have one?
Yes, I am unmuting my macro, and I am not so long in the spectroscopy, but I'm more a technician. But it was very special to use this eShel and the new Demetra software. I am a little bit older, so it's not flexible, my mind, to take everything, to absorb everything. But the output of the system of Demetra is very, very flexible, and all the steps are very fine detailed. And one thing that is special, that's the color, different colors that you see in the buttons. So if you have a green light, then it will say that everything, all the calculations, everything what you need to have a good result is present, and that is fantastic. If there is some not a green light, then you can go back and see where the difference is and where there is a problem, and that's very easy. It's a pleasure to work with, and I hope together with the team of Ghent to go further on, and I am looking forward and see what we can do with the equipment, because we want to catch, like Guy said, to catch a maximum of light in the small fiber.
Thank you.
So thank you for all your information.
Eric, a few words to conclude the meeting.
Sorry, I just have to tell you, I have to go to the next meeting, so I'm going to have to leave you.
Okay. Bye. Thank you.
Bye. Olivier, I didn't let you have the opportunity to present you.
No, you asked to Eric. Eric.
Oh, sorry, Eric.
Yes.
A few words to conclude.
Sorry, I was out for about 20 minutes. Does you want to
just to say if the meeting is the workshop meets your needs, and if you have something to add or to.
It was very interesting to follow this meeting and to see the faces after the behind the names. It's very interesting as well. Demetra is a very fine software to work with, and together with our colleagues of Ghent, we use this further, of course. I don't have an eShel by myself, but the colleagues of Ghent, it is very interesting to use this software. Also, the reduction is very fast, and yeah, it's very well. I don't know in the future if there is an add-on also for the LIRES spectrograph planned or not. I don't know, but at the moment I work with Aldela and SPC POTAS software, and okay, it works also very well.
Thank you.
Okay,
that's all.
Well, just a quick comment on the LRS rate, because this is a demand. We have this demand from time to time, and I know that a lot of people would like to. The small problem we have with the LRS is that we can rotate the grating, and then we don't know exactly where we are in the spectrum. And because we are in a very high resolution, we cannot apply the same automatic calibration algorithm that we have today for the ALPI or for the eShel, which is exactly the same algorithm. So we have to do something else. So we have to invent something else. But I'm optimistic, because I think that we you know that we are working on a new instrument currently, which is the UVEX, and for this one you will also have a rotating grating. So we'll have to do something else. So I hope that when we have done the job for the UVEX, it will be easier to apply it to the LRS ray. But again. It's just a question of time.
Okay, thanks.
Sorry, Olivier, I forget you in the presentation. So please, could you conclude a few words?
Me?
Yep.
Well, I just say some. Just to begin, I just some few words to introduce myself for some people who don't know me. So I'm Olivier Garde. I work for Sheliak Instrument since 2 years now, I think, as a communication manager and the technical consultant for all the products in Sheliak. I have a remote observatory at home, so with a 2 Richter-Chrétien telescope of 30 centimeters and 40 centimeters. And I use these 2 setups with eShel spectrograph, LISA spectrograph, and the great big one WHOOP shell spectrograph on various targets like Biostar, planetary nebula, or cataclysmic star. So that's why I try to do all. I try to test all several spectrographs from Sheliak. And what I think about this meeting, it's great because we have the background of all the users. So it's important to have your feeling and to try to understand and to improve our equipment or software with your background. So thank you very much for all.
Nicolas?
Hello, I'm Nicolas Durand. I'm the Demetra software developer. I started to develop this since 8 years with François. I love to build software that are used by people and directly by people. Developing it is a really nice job. I don't know to say that. And listening to you and your feedback is very interesting and a strong feeling too. I hope that I will work for and we will do it to match better and better your need. Okay.
Thank you. Our aim in this workshop is to provide you some information, but about spectroscopy, astronomy, and so if you have in mind any topic you would share with other people, we can organize other meeting, and we try to organize meetings once a quarter or something like that, with of course information about celiac instrument, but if you have some if you have some topic, please send me an email and we'll try to organize it. The last word for François?
Oh, the last word is thank you very much. It was very, very interesting to see you, to see your face, to have your comments, your questions, and your great, great comments. Thank you very much.
Thank you. Bye-bye.
Thank you very much too.
Bye.
Great thing.
Bye, everybody.